Okay, so here's question 10 from 4.1. So we've got two equations. We've got two dependent variables, x and y. So what we're going to do is we're going to solve for the highest derivative of the variables that we've got. Okay, so we've got to solve for x double prime and we're going to solve for y prime. To get rid of x double prime, it's fairly straightforward because we see in both equations there's an x double prime. So we can replace the x double prime on the first equation by the left-hand side of the second equation. So we get y prime plus 2y plus y prime plus 2x minus 3y equals 0. So we just got to solve for y prime. So y prime then is going to be 1/2 of, we just put everything over the other side. So we've got the 2x on the other side becomes a minus 2x. 2y minus 3y is minus y. On the other side becomes a y. Okay, and then to solve for x double prime, we see we can get rid of y prime, right, by just subtracting the two equations together. So we get x double prime plus y prime plus 2x minus 3y. We subtract over here minus y prime minus 2y equals minus x double prime. Okay, so these guys cancel out. This guy goes over here. So we're left with x double prime equals, and again we get 1/2. And we put everything over this side. So what do we got? We've got a minus 2x and a minus 5y. Fantastic. And so our solution then is we let x1 equal x, x2 equal x prime, x3 equal y. And this shows you that it's three-dimensional. And we get, of course, we get x1 prime equals x2, x2 prime equals, equals, what does that equal? It's down the bottom here. It's equal to minus x, which is minus x1 minus 5 on 2y, which is x3. And then finally, we got x3 prime, that's our y prime, that's equal to minus x, which is minus x1 plus, yes, plus y, which is x3 divided by 2. Okay, on to the next question. Okay, and then question 12 from 4.1, we had the spring set up. So we've got two masses connected by 3 springs. And so we want to see what the forces acting on the first mass is. Well, the force is going to be, of course, mx1 double prime. And what forces is acting on that? Well, we've got from the first spring, it's just minus kx1. And then from the second spring, that's going to be, what's it going to be? That's going to be plus 2k, because it's doubly strength. And what is the length of that spring going to be? That spring is going to be x2 minus x1. Okay, and so all together, we're going to get, what is it? Minus 3k x1 plus 2k x2. And then we do the same thing for the second mass. It's going to be, the third spring is going to act like that on it. And again, there's going to be a force acting on the that mass from the middle spring, and that's going to be minus 2k x2 minus x1, since the force is going in the other direction, and that's going to be, that should be minus 3k x2 plus 2k x1. Could probably figured that out by symmetry. And so that tells us that this is a four-dimensional system, right? So we're going to let x1 equal x1, x2 equal x2, x3 is going to be at x1 prime, x4 is going to be x2 prime, and then the other two equations are going to be x3 prime is going to be what we get from that first equation there. We solve, what are we going to get? We're going to get minus 3k on m x1 plus 2k on m x2, and x4 prime equals minus 3k on m x2 plus 2k on m x1. So this is a four-dimensional linear homogeneous system.